My name is Daniel Lee. This is Levi Van Stetten. For the NASA Exploration Systems Mission Directorate, we have developed software and a platform for robot arm controls that will be demonstrated in this presentation.
Our methodology that we chose for this project included a high-level design approach which incorporated modular subsystems. These subsystems included a master control unit along with multiple slaves. The master utilized a wireless technology, also a keypad and LCD, whereas the slaves utilized the same wireless and LCD technology but also incorporated DC motors. This is the robotic arm that's connected to the H-bridge side of the PIC training module that's supplied by ODU. This particular arm has 6 DC 24-volt motors, which gives it a total of 6 axes full rotation. Of those 6 motors, our project utilizes 4 of those, and 2 of those 4, this motor here along with this motor here, are connected with 2 limit switches, and the motor here and the motor on the base are only utilizing 1 limit switch.
This is the ODU PIC training system. It comes with a keypad, an LCD module. For our senior project, we're using the PIC 16F877 Alpha and the MRF 24J40 MA transceiver. Levi will now explain how it interfaces with a robotic arm. This is the master controller. As you can see, on initialization, the software loads the general purpose registers with the required values for our program. After initialization, our program starts. The first display requires the user to select direction, either forward or reverse. As an ODU requirement, each selection requires feedback to the operator. As you can see, a debounce is the first display asks the user to input direction, either forward or reverse. In this case, we're going to select forward. As you can see, forward selected is fed back to the operator. The next selection is speed, slow or fast. We're going to select slow. The next selection is duration, short or long. This is how long the motor is going to run for. In this case, we're going to select short. Next up is selection for motor A or B, or both. Each slave contains 2 motors. Motor A runs motor A, motor B runs motor B, and both runs both motors at once. In this case, we're going to select motor A. The next up is select the slave, either 1 or 2. Our software is modular and we can input as many slave modules as required. In this case, we're going to select slave 1. Next up, you're asked to confirm the parameters, and the display feeds back each parameter to the operator. If the parameters are correct and yes is selected, the next display shows sending. Right now, the selected parameters are being sent via the wireless transceiver to the slave module. As you can see, once the data is sent, data sent appears and the program starts again. If for some reason the parameters are incorrect, no can be selected and the program starts again. This is the master where we're sending from, and over there is where we're receiving. Once transmit is selected, the slave will state receiving. The raw ASCII data is then shown along with a short description of what has been sent.
Once the motor has either extended itself to reach the limit switch or has run out of the motor duration time, which is the time delay built into the program, that completes 1 full cycle of the instruction set. Next, we'll go ahead and move another appendage of the arm here. This time we're going to be utilizing slave 2 by slave 1, which is on the original data that was sent. In this condition, the limit switch has been reached, which has stopped the movement of the arm. This is to limit the movement from binding the mechanical limits of the arm. The next movement is also completed by slave number 2. This is the motor with 2 limit switches connected here and here. This allows the program to understand a little bit better on where the actual motor is in relation to itself. Again, the movement happened until the limit switch was set here, which turned the motor off, which again limits the mechanical limitations of the robot arm. The final motor that we're going to demonstrate is motor B, that is attached to slave 1. This motor acts as a wrist for the robotic arm and is attached to a single limit switch. Again, every motor has 2 separate durations, a long duration and a short duration. These durations have been fine-tuned for each joint specifically to allow a certain amount of movement per joint. As stated earlier, this project uses 2 slave boards. Each board drives 2 motors. This slave board here is responsible for driving the motors that have 2 limit switches connected. Each limit switch is connected to a debound circuit utilizing quad 2-input NAND gates. These NAND gates are also attached to these LEDs, which indicate to the users, be it us, when a particular limit switch is closed. This was used during the troubleshooting process of the code to indicate any problems that we're running into. The power that drives these motors is brought in from the H-bridge, which is located here on the board. Here is a connection to a 24-volt power supply, which is used for the high voltage side. Each one, there's 4 of these per motor, and depending on the selection of being forward or reverse, depends on which 2 are turned on or turned off at the same time.
To identify each slave has its own individual short address. This is selected in the master as to which one is ready to receive, and it will be hard-coded in the slave.
Finally, this is slave 1 board. Again, this board only is still connected to 2 motors, but each motor is controlled by a single limit switch. That's why there's only one a NAND gate IC chip there. Again, we use the LEDs here to indicate a limit condition. This condition here is set right now. This one I'm setting manually with my finger.
What we're going to do here is run all 4 motors at once, so both slaves running. We're going to have them all running in the same direction, so we select forward, have them running in slow so you can actually see it. The duration is either short or long. We're going to run long. In this case, we're going to select both motors, and the slave we're going to select first is slave 1. Now that slave 1's been selected, we're going to confirm our parameters: forward, slow, long, both, slave 1. That's correct. We're going to confirm, and the data is now going to be sent to the slave.
The code from the master board is being sent to the slave here. As you can see, it's receiving the code, decoding it, and it will spit back to the user the same information that was sent over there for verification. In this case, forward, slow, long, both motors and slave have been selected. It sits at this point until a go word has been sent from the master controller, which will ultimately drive the motors.
Now we're back at the master, and as you can see, it's asking if you want to run more motors. We want to run slave 2 in this case. So we're going to select yes. And again, the same parameters are input. Forward, slow, long. Again, we'll run both motors. And this time, slave 2. Again, we'll ask to confirm the parameters. Forward, slow, long, both, slave 2. That's correct. We'll send it again. Now this is being received by slave 2.
As you can see here, slave 2 is receiving the command sent from the master controller. Again, the data is represented for the user to verify that the correct data has been received. Forward, slow, long, both motors, slave 2. At this point, both slave 1 and slave 2 are ready to receive the go word in order to move the arm.
Okay, again we're being asked for more motors. In this case, we don't want to select any more. And we have the option, press 1 to run the motors. Now we're sending a go word.
Both slave 1 and slave 2 are now currently receiving the go word. They are again relaying this back to the user, letting them know exactly what data is being sent and received. And as soon as both motors get the information, the motors will start moving. Now the master controller is sending both go words to the slave 1 and slave 2. Slave 1 receives the word first, has a delay of 5 seconds. Slave 2 receives the word second, and at that time all 4 motors will move. As you can see there, all 4 motors have moved. They've either hit their limit switches, which prevent it from extending past its mechanical limit, or the time delay has been exceeded. This time the direction for the motors are going to be given in the opposite direction to show mobility in both forward and reverse for all 4 motors. Again, the go word has already been sent with the new commands to slave 1 and slave 2. First slave board's already received it, second one has just received it, the data in, now it's moving.